Hello flatties and globe defenders, it's Critical Thing from Down Under. Today we're going to look at a video that shows the Isle of Man is visible from Southport in the UK. And a lot of flatties would like to believe that this is solid evidence that the Earth is indeed flat. But I'm not so sure about that. Let's have a look at this video and do some analysis on it, shall we? The title of this video is The Isle of Man, 676 feet below the horizon from Southport, by exploring the plain. Now in the video the Isle of Man is not below the horizon, so maybe the title could be better, but never mind. We get the idea. The video has been mirrored by at least 5 Flat Earth channels, so clearly they think this video makes an airtight case for a flat Earth. In reality, like all these see too far videos, it supports the globe model rather than making a case for a flat Earth. I'd like to commend the author of this video. They've done a great job, gone to a lot of trouble, and spent a lot of time to give a good presentation, including evidence of observer location. Unfortunately for flat earthers, a well-documented observation also allows us to determine that the observation shows that the Earth is indeed not flat. There is nothing wrong with the video, however, the conclusion of a flat Earth is incorrect because of false assumptions and a largely superficial analysis. The logic goes like this. I can see too far, therefore the Earth is not a globe, therefore the Earth is flat. That's about the depth of thinking on this by flat earthers. I will now do a more comprehensive analysis of this video. Now there are videos on the internet which show that the Isle of Man can be seen from Blackwood Promenade. Yes, there are. And there are photos as well, many of which are taken by people who know that the Earth is a sphere. It is then claimed that this should be impossible due to the curvature of the Earth. Nope. A basic misconception by the author and by many flat earthers. This would be true if the Earth had no atmosphere. However, the air we breathe cannot be denied, and this air has a density gradient, and light bends in a density gradient. More about this later, but we will continue for now. This video has footage which shows that the Isle of Man is visible from Southport, and Southport is almost 8 miles further away than Blackpool. No argument there. Here are the assumptions and claims of this video. The author uses the assumption that the Earth is a sphere of radius 6371 kilometers and that light travels in straight lines to arrive at the conclusion that on a globe the Isle of Man should be 676 feet below the horizon. Note that he uses the curve calculator and Google Earth to make these calculations, both tools brought to you by the same people that know the Earth is a sphere. I think it's highly amusing that flatties don't have their own calculators and maps, so they use ours. And this is a good demonstration of the consequence of using tools you don't understand. This calculation would be okay if the Earth didn't have an atmosphere. But because there is an atmosphere, and consequently the bending of light around the curve, the use of this calculator is invalid to model the real world. However, I want you to take note of 2 things here. The first thing is the claim that light travels in straight lines. Remember, this is a claim of this video. Secondly, the approximately 960 feet of curvature that is missing because of this assumption, and that's made up of the 676 feet hidden, plus in the video there's another about 290 feet showing. But wait a minute, as I explained, that's not the real world globe model. So for the rest of the video I will compare the observations with the flat Earth model and the accepted globe model. We will see which model best fits the observations. The assumptions of the flat Earth model are that the Earth is a flat and motionless plane, and that light travels in straight lines. The globe Earth model is that the Earth is a sphere of radius 6371 kilometers and light is refracted by the atmospheric density gradient. So we start by verifying observer position and height, and I've had a bit of help from my fellow Wolfpack member Ruhif with this video. He was looking at this video and we talked about it, and in the process I did quite a bit of analysis and we came to the agreement that it would be okay for me to produce this video. Ruhif loves looking at these types of videos and he does some excellent forensic work on C2FAR videos. He has a good record in debunking them, and you can see many flat earth claims surgically taken apart on his channel. After spending several hours trying to match the landmarks to this picture, I realised that this isn't the War Memorial obelisk at all. It is in fact the Marineway Bridge to the right there. After changing that landmark, everything fell into place fairly nicely. Now, because it's low tide, we've estimated the observer height at 18 metres, and by matching to the correct landmarks, the observer location is verified as being within a couple of metres of the stated location. Ruhif has made a little utility to analyse the data from an image, and we tested it out on this observer location. And this result is shown in Google Earth, and you can see that the utility has correctly identified the area where the observer would be. To do the modelling, we've identified a couple of other landmarks. There's the eco-centre turbine, and there's a pole there on a nearby roundabout. This is the Marineway Bridge, which is the tall structure to the right of the picture, and there's the turbine, and that's that pole. So this is a rendered globe image with a refractive index of 7/6R. You can see the landmarks I've rendered into there, just as some sticks and a little yellow block to the left is the jetty. The elevation data was downloaded from this Earth Explorer site. We can check the render against the photo and it matches reasonably well. The turbine is a little out of place, but this is most likely because the observer position is off by maybe a metre or maybe less than that. Everything else lines up pretty good. There are some extra mountains in the render, and I didn't think it was worth the time to check it, but most likely they are further away and are not visible. Now this is the flat Earth image, and this one is rendered at a higher resolution, and again the turbine is off a little in the same way. The mountains are higher, but the difference is not big enough to call. The globe and flat models are similar because the distances are not very large in this picture. The video in question also contains an observation to the north to Blackpool. Notice how the mountains in the background are about halfway up the tower. There are some easily identified landmarks there, the big one, the ice blast, and of course the Blackpool Tower. Similar to the other observation, we can render to the globe model with 7/6R. And look at that, this matches very well. And we'll overlay the images and compare, and you can see that's pretty good. Now we render to the flat Earth model, and you can see those mountains in the distance are now way too high. They're over the top of the tower compared to the photographic image, and this becomes obvious that something is rotten in the region of Blackpool. So this frame grab clearly shows a curvature drop of the amount predicted by the globe model, and no prizes for guessing which model best fits the observed reality here. So here, flat earthers, you have a problem. A video that is supposed to show a flat earth actually shows the curvatures predicted by the globe. That's a bit embarrassing, isn't it? Let's move on to the primary target observation of the video, the Isle of Man. I've taken this frame as the best one to be able to perform a meaningful analysis. Let me point out a couple of things. First of all, you can see the top of the platforms are about the same height of the highest mountains on the Isle of Man. I found some solid data on the DP4 platform, and that arm extending out to the right is 43 meters above astronomical low tide. So that is the maximum height it can be. The other thing to notice is that the mountains are not very high and the platforms are compressed vertically by about a factor of 2. So the question is, if the Earth were flat, where is the rest of the Isle of Man? Snowfell is supposed to be 621 meters tall. You can calculate the angular distance between the two platforms by taking their bearings from the observation point, and then it works out to 1.32 degrees. This gives a scale in pixels for the picture, and knowing that Snowfell will have an angular size of 0.30442 degrees, and on this picture you can only see 0.04 degrees above the water. So the majority of Snowfell is still underwater. As illustrated there, the arrow drawn, vertical arrow, is where Snowfell should appear if the top of it was as in that picture. This is impossible for a flat Earth. Don't forget that the assumption in this video is that light travels in straight lines. Therefore, compression is impossible with this assumption. Also remember, this video was complaining about 960 feet or so of missing curvature, but here we have 1750 feet of missing Isle of Man. That's twice as much. Isn't this a clear problem? Flatties like to claim that the whole of the Isle of Man is compressed into that 0.04 degrees above the water. First of all, that would mean a 7 times compression, and we can only observe it 2 times right there. Secondly, light travels in straight lines, remember. I'm sorry, you have already claimed in this video that light travels in straight lines to rule out the globe. Sorry, but that rules out flat Earth as a possible explanation for this observation. And now this compression thing is totally unexplained by the flat Earth. There is no science for it on a flat Earth. However, the compression is a natural consequence of refraction over the curve in the globe model. Take a look at the excellent work done by Mick West, and I'll put links in the description to model it and test it. It's testable, repeatable, and observable, some of Taboo Conspiracy's favourite words. Take a look also at the videos done by Ruhif on refraction. You can't deny refraction exists, flurfers. This video shows that it does, and this is a flat Earth video. Now let's take a look at the rendered models of this observation. First, the flat Earth model. Notice how this looks nothing like the observation that I've just shown you. Now the mountains of the Isle of Man would be much higher than the gas platforms, and this observation does not support a flat Earth at all. And if you've mirrored this video, you are supporting the globe. Next, we have the render of globe with no refraction. And you can see, yes, the Isle of Man is over the curve and you won't see it. The interesting thing to note here is, as I have noted before, the difference in the globe model with no refraction is only 960 feet, which means it is 960 feet lower than what we can observe in that video. But the difference in the flat Earth model is 1750 feet. So in the flat Earth model, it should be 1750 feet higher than observed. So what can you say? There's 2 times the difference in height of a flat Earth and a globe. So the globe's closer. Now we put in render with standard refraction, and the Isle of Man is still not visible. And we know that there's an extreme level of compression observed, so refraction is much more than would be present on a normal day. So if it was a normal day, there would be a claim of limit of sight, or angular resolution limit, or some such pseudoscience by the flatties. Yet isn't it strange that when you see the Isle of Man, as in this video, suddenly there's no such limit of sight, there's no angular resolution limit or some such. The explanation is the Earth is flat. And we increase the refraction K factor for a render. We don't get an image that matches the observation. And the gas platforms are still submerged. And this is because in this particular model that Ruev has built, it does not do the variable refraction that would result in compression. However, Mick West has produced a model with that, and maybe we'll get some time to build that into this ray tracer. Hey Ruev, what do you reckon? Well, in summary, this is another flat Earth video that supports the globe. Flatties, you just cannot continue to deny that light is refracted downwards by the atmospheric density gradient, causing objects to appear higher. And observations over long distances of water should be accompanied by some reference observation or a measurement of the amount of refraction. Yes, wide awake, this means you and Andy. It's all too easy to observe something refracted higher and then claim the Earth is flat, forgetting about all the other ways which we know it's a globe. I won't go into that now, but in this video about the Isle of Man, you can see that an observation over water may at first glance make it look like the globe is broken, but a careful analysis makes the flat Earth impossible again. In this very same video taken by a flat earther, it is shown not only that the Isle of Man should be 1,750 feet higher, but that north to Blackpool, curvature can be seen evident in the observation of the mountains in the distance. Thanks for watching, and remember we still live on a spinning ball.